I'll just share my screen. Please confirm.
Yes, it's visible.
Okay,
Yep.
great. So yeah, so revising what we explored day before yesterday. So we explored on mainly the framework deep eval, right? So we checked through the possibilities we have with the deep eval and what are the context it lets us to evaluate, and we checked through the code on. So we connected our Llama model, Llama 3.2 and other models, right? And we tried to generate something, so answer some query, and we were checking with. So how does this deep eval lets us check through the context and everything, right? Uh, to be exact, so yeah, how grounded it was to the actual truth. That's what we were checking with this deep eval, right? So we had given a context, and the context we gave a query, and whatever the response came in, so we were checking with how grounded it is, how faithful it is, right? So that was our agenda as a day before yesterday. So today we will be exploring more on, we have to remember one thing that this deep eval we can construct it locally too, right? So it is using the same pydantic which we discussed, the OOPS concept which we discussed again, right? And also how to connect to local model which we have discussed already, right? So all these things, it is connecting all this, and it's a framework. So in order to use it like a standard procedure, we can use it. And the major thing would be like it has got its own great built-in prompts which we can use. And since they are common across the industries, so we would get a similar metric to evaluate any model or something like that. Okay, so that's the major advantage of using these frameworks. Yeah, with that, let's get into something which we have discussed already, but let's get into like in depth. So yeah. So I just revised the day before yesterday class. Any doubts you got? Not, we'll move ahead.
No, no, we
Oh,
can go ahead. I will.
first, uh, so today we will be discussing on RAG. So I have already explained you what RAG is, right? So there were few words which we have discussed already. Embeddings. Okay, we had embeddings. We had something called vectors, which we discussed, and we haven't discussed, but we did spoke of like vector databases, right? Similarity check. Okay, so for this, it is cosine similarity usually, but there are other methods too, right? Yeah, so we have discussed. So you guys know these words, right? Uh, as of this session, maybe not in depth, but yes, you know these words. We have used these like to explain to you certain things. So yeah, so we will be discussing on RAG today, and in order to understand the RAG, the retrieval augmented generation. Okay, in order to understand this better, so we would be needing to understand all these words. Okay, right. So as of this point, like have you guys like should be having some idea on like what's RAG is. So may I know like what's the idea so that I can construct over the same base idea. Manavya or Saurabh?
Uh, Bringing the data, retrieving the data.
Okay.
Right now, I
So
could learn only that.
mhm. Saurabh, got an explanation?
Come back again. Explanation regarding which one?
Like like what's RAG? Have got any explanation for it? Have you got any base idea?
No, like completely new for me. Like I think
Okay.
Retrieval-Augmented Generation is something that I'm hearing first time. No guesses.
Oh. Sure. Let's have an analogy instead of like explaining it in a technical term. Let's have an analogy to understand this better first, so that we can turn like overall idea of it and also understand the means around it if we get into Instagram or LinkedIn, right? So yeah, so you read whole year and at exam, you send it to this exam. There is a question paper and you try to answer this, right? So you have been trained over this data, whatever the questions is, right? Syllabus. Okay? You have been trained over the syllabus for almost 1 year. Okay. And depending on like whatever you have understood and whatever you have already trained on, so you're trying to answer these questions. Am I right? Can I call it like
Yes, yes, yes.
LLM? So we have trained it on certain data. So it knows some generic sense and it knows like how to create a sentence, how to understand it, and it knows some facts. It knows the internet data. So can I say that I have been this LLM is trained on this data and now it answers our queries depending on that knowledge. So let's just say uh, again. So what is RAG is, so you have this question paper, you have to get the answers. Yeah, you have been trained like for these questions on syllabus for almost 1 year. The same, okay? But this is like open book exam. So what you can do is this intelligence has got feature of accessing this notebook. Okay. So this is of open book exam. So you can refer books, whatever books you get, like you can refer them in order to answer these questions. But again, you have been trained, you have been learning everything well for a year. You have that intelligence already, but you have access to other external knowledge now. Okay, in order to answer these questions. Okay, so we call it open book exams, and these are like traditionally closed book exams, closed room exams, whatever. Okay, no worries. So this concept itself is nothing but RAG. Sorry, RAG. Okay, and this is how our LLM got intelligence. Okay, and this is Billy's LLM. This is the engine. Okay, it understands already the sentence formation, the words. It understands English. It pretends to at least. Okay, so knowing LLM, we shouldn't say it understands. It pretends to understand. It simulates the intelligence already, but now it has access to external knowledge. Okay, so it is there is a query and it is referring back the external knowledge, and there it is getting some concepts which it is referring back, and with the intelligence it has got, it is answering those questions. Okay, this process itself called retrieval augmented generation. Okay, it is retrieving, it is augmenting the knowledge, and then it is generating. Make sense? I hope this analogy you can find out all over the internet. And yeah, so if you compare LLM as a brain, so this open book is like this RAG is having an extra book which you can refer. Okay, so that's basically an extended knowledge. I hope you got an idea.
Yes, yes, yes.
Yes, yes. So RAG, is it only in AI or it's actually in every technology, right? No?
Not actually. I haven't heard of like RAG in other technologies.
No, I
So
mean to
this,
say the function that what RAG does. Uh, I mean in different technologies also they have different names also.
hmm, okay, the technique could be like copied. So that's fine. But may I get an example on like where you are saying this? Around like
Yes.
any example over like
No,
where you are
no,
saying
I'm
this?
just generally asking, like even
Okay.
we bring out the data and from when people work on data of the customers or anything else. So that's also called RAG or no, no.
Yeah, maybe like I'm getting your doubt, but I'm not clear like if that's the doubt you are asking. So let's do one thing. Let's understand this as of today's session, and by the end of the session, you can like ask me the questions, and maybe we will get
Yeah, yeah,
clarity
sure.
over the question and answers too. Okay.
Yeah, sure.
Yeah. So we will get to know like what kind of uh, applications we would be building with this technology. That is the RAG concept. So it's basically a concept. Yeah. So static memory is what LLM have, okay, and dynamic memory is having an external knowledge source. Okay, this can be changed every time. Okay, there is an update. Okay, there is an update. You can update this knowledge. Okay, you want to change this knowledge as whole? Yeah, you can change it. No worries. So since now LLM does have its own abilities, but it's just that it is connected with external source, and that's why we can call it as dynamic reality, or here it is considered to be static memory. Okay, so once it is trained, let's just say it is trained for 2025 data. Okay, LLM can't predict anything that happened in 2026, of course, right? So because the cutoff knowledge itself is of 2025, so that becomes the temporal data that went after 2025, right? That's not available for LLM. So no way it would be trained. Okay, but by integrating this data with this LLM can understand the things already. Okay, it simulates the intelligence. So now by providing this 2026 data, we can ask any questions to this. Okay, uh, so what does Gemini does, or the Google's AI mode does? It has got its intelligence. Now every time you search something into like AI mode, what it does, it is connected to some external tool, that is web tool. So it searches the web, so it gets tons of information. Now, since it has got its intelligence already, so now it understands the details from the web tool, all the websites, and then it responds back. Okay, doesn't matter where the knowledge cutoff happened for this particular language model, because it understands the language already. Now we can integrate it to like external data. Make sense? So yeah, the closed book exam and the open books exam. So that's the one example we could take. So let's just read it. Standard LLMs rely solely on the internal weights. If weights means like weights and bias, if you remember. So every time a deep learning model or transformer learning model actually runs, right? So it trains. So there are weights and bias that's been set into its neurons. Okay, those are the weights they are mentioning. If data wasn't in the training set, the model has no choice but to guess hallucination. So if you ask this 2025 LLM trained LLM model that what happened if in 2026, okay, summarize 2026 for me. Okay, it can't, but so LLM have a tendency to answer quickly, right? It has a tendency to generate tokens to predict the things. So now it actually hallucinates. That's what is being spoken here. It hallucinates. So that's why instead of providing this, so we create an exact paragraph needed for the model. So we provide the context that's needed for this particular model. And since it it has got intelligence and knows the language, now it can respond back pretty well. Okay. So with this, like, yeah, that's the concept of RAG. So how it does it, yeah, we will be understanding that. Okay. So you know embeddings already, right? Okay. So what are embeddings? We have seen word embeddings. Let's just say king. So now it has got like 796 dimensions maybe. Okay. So you have to set coordinates for 796 dimensions. So you may set it like king, he's similar to like he's human first. Okay. He would be common man with power plus power, we can say, or human with authority. Okay. Supreme person in like in that state or city. Okay. All this, there are characteristics to define a king, right? So those characteristics will fill all these coordinates. Some data will be there, some coordinates. So for this particular dimensions, this is a coordinate, and this could be like your XY axis, right? So we have know this already. How explain this. So x-axis, y-axis, let's just say marks 1. Okay. So for this particular child, the marks is like 90%. So this is the mark. M1 is 90. For science, let's just say. For maths, it is 60. Okay. The coordinate of this particular kid would be something like 90, 60. Okay. Where these refer to his science marks, his maths marks, right? So similarly, there could be n number of coordinates. So here we are considering example of 796 or 718. Okay. So there could be any number of dimensions. So here there were 2 dimensions explaining 2 concepts relating to 2 particular values. So here there could be like these number of values. So depending on like where the king fits, depending on the training data that model had, depending on that, the coordinates will be generated here. Okay. So we got a rough idea of like what's happening here, right? So we have already discussed embeddings already. If not, we can discuss it again with an example. That's fine.
Yep, let's discuss with example also.
Okay, great. So let's just say a cat and a bird. Okay. The characteristics to create these embeddings would be something like, so there could be n coordinates. Okay. So let's just say the first value is, does this animal have any legs? Okay. Does bird have any leg? Yeah, they do. If cat have any leg? Yes, they do. Okay. The coordinate would be like something like 1, 1. All the birds do have legs and all the cats do have legs, right? So 1, 1. So the next coordinate would be number of legs. Okay. Sorry, two legs. Okay. Bird have 2 legs, of course. This is bird, this is cat. But as of cats, they have 4 legs, right? So can I say 0? Next would be like 4 legs. So for this, birds would be 0. And so do you guys know any bird which have like 4 legs? Because I don't think I know. So,
No.
so let's just say fur. Most of the cats do have furs, let's say 0.8. Okay, but because there are cats which have like only skin, some hybrid cats. Okay, so no fur. So are there birds with fur? No, right? So 0. So feather, yeah, that could be another characteristic. And let's just say vision. Okay, so cats are binocular vision. Yeah, right. So birds, they do have binocular vision at some few of the birds, and there are none. There are other birds which have like 360 view and everything, right? So can I say 0.4? At least 40% of the whole birds do have binocular vision. Okay, so that's lay eggs. So there are exceptions in birds also, which don't lay. Uh, so let's say 0.99. Okay, only 1% of it. Cats never lay egg, so let it be 0. Okay. So similarly, there could be a number of characteristics. So when I say dimensions, 796 dimensions, there could be 796 such columns, which should be fulfilled. Okay. Depending on, let's just say this was like 1, 2, 3, 4, 5, 6, 7. So this was of 7 characteristics. Okay. So what's the embedding for bird would be 1, 1, 0, 0, yeah, 0.4, 0.99. This is an embedding for bird in our case. Okay. How this is being decided, these values, they are being decided depending on the training data set of like how that model is trained. Let's just say there is a model LLM that is trained only on cats that have fur. Okay. So it has not been exposed to any cat which doesn't have fur. So this LLM would create an embedding for a fur. If cats have fur, it would create embedding like 1. Okay, because it has never been exposed to the data where cats doesn't have fur. So imagine this LLM is trained only on that data set where cats have no fur. Okay, now this LLM would think cats would never have a fur. Okay, depending on this, the value would be, if they are exposed to both the values. So depending on the training data set, it could be 8%. 80% of the cat have fur and 20% don't have fur. Okay, so are you understanding how these values are being configured? Guys,
Yes.
any doubts at this point, like how these
No.
embeddings are created?
No.
Yeah, depending on all these characteristics, right? So these will be decided depending on the training data. Again, when once it is trained, once the model is trained, now it can create embeddings. So these embeddings, so all these number of characteristics, whatever the value may be, so all those together will form coordinates. Okay, and this what we call as vector. So when we say vector mathematically simply means a set of like string of words. It's a mathematical representation. It would be like coordinates. So in term of like technical details, they are called embeddings, but they are also called like vectors. Vector is like usual term which we use. Okay. Uh, yeah. So I hope you are clear with embeddings. So yeah, here I have given a classical example on this. So king minus man plus woman becomes queen. The logic, is it understandable? King minus man is like an authoritative person, a human being maybe. So he's not a man, but he's a woman. So we can call her like to be queen. Okay, that's the logic. So how these embeddings are created, even though all the English words may not be exposed with this LLM, but it tries to understand like depending on like the training data that's already been exposed, right? So it tries to get the synonym of it, like gets to understand like what it is. Okay, so it understands something like this. So king with an authority, so he's an authority plus human, who is man. So minus man means king plus human. So plus woman, that becomes a queen. So that could be like a simple logic in order to understand this. So it doesn't work like that, but yeah, we can understand this better like this. With a bird and cat analogy, you would be already understood it better. So no worries. Okay. An embedding model converts text into an array of numbers that they are coordinates. Similar meaning land in the same mathematical neighborhood. Okay. Let's just say, uh, so let's just say I put up like street dog. Okay, with German Shepherd. Okay. Okay. So since both are dogs, most of their vector representation would be similar, but not exactly same because they have differences, correct? The vector where it lies, the embeddings that are created, most of the values should be similar. But yeah, there could be different. There are differences between street dog and German Shepherd. So there would be little differences, but these would be very similar. So that's being discussed here. Okay, king and queen, except that they are like there is a difference in gender. They both have the authority. They are both humans and they are valued beings in a city or let's just say in a country, right? So they may have somewhere these vectors may have very similar or very they are placed very near in a database. Okay. So imagine, so when we said x and y axis, okay, this was of 2 dimensions, right? So if we create z axis, this is of 3D. Sorry, 3 dimensions. Okay, z axis, we are this is of 3 dimensions, correct? So we live in 3 dimensions. Whatever we write on paper, that is 2 dimensions, right? So 1 dimension would be single point, correct? No length or breadth. So here we have length and here we have breadth. So imagine 718 dimensions, right? So in 3 dimensions, we place something. We have 3 coordinates: x, comma, y, comma, z. So let's just say there are like 718 dimensions. For the same, the embeddings would be 718 dimensions. Within that dimension, somewhere that particular vector, this particular vector for street dog or German Shepherd lies. Since they both are dog, they may lie into like similar. Since the embedding is similar, they may lie somewhere similar in that particular space, in the 718 dimensional space. Understandable, guys?
Yes.
Right. So yeah. So here basically what's being discussed is, so with vector and embeddings, right? we can actually check through the meaning of the text. Okay, it's not about words. It's not about like street dog and German Shepherd. It's not about the single words. There could be one statement where I could say, Arya is taking class. Okay, and there could be another statement where Arya is some X-year-old. Okay, so here both the things are being are spoken about like Arya itself, right? He's the only person. They could be like different statement, but they are speaking of like only Arya. So these could be like the embeddings for these statements could be of similar set where the Aryas, it's an Arya's domain, and where all the information about Arya could be like in or of similar embeddings. Okay, they could be like very near coordinates. So when I say near coordinates, they are more like, so let's just say it is Virat and here is Rohit Sharma. Okay, they are very good cricketers, Indian cricketers, right? So they are very old cricketers. They also play in Indian team. So they score like similar. Yeah. So can I say these both the vectors for these? So if two vectors are created, Virat Kohli and Rohit Sharma, they would be of very near to each other. Okay. Let's just say somewhere Arya, who is a gully cricket player. Okay. So the distance between the vectors from Virat or Rohit Sharma would be like too much. Okay, this could lie in some other yeah, the dimensions are constant, but the values within those dimensions could be different, right? So the distance between these two vectors could be like way too off. Understandable how these distances and how these vectors are placed in the vector space, maybe. So yeah, since it actually calculates through the meaning of what's being discussed or to whom it's being discussed or it is what it is being discussed about, right? So that's why, so the traditional if statements which we wrote, okay, if this exists, okay, if this exists, so LLM plays with the words. Now using Python, we were actually trying to check through the words. Okay, that doesn't make sense. That's why using this vector search, we can actually get efficient results on what are the similarity and which statement actually supports this particular query and everything. Okay, so traditional search, we used something like in a if statement or something like that. Okay, in semantic search, we actually check through the similarity, that is cosine similarity. This could be angle between those two vectors. Okay, if the angle is very low, if the angle is 0, they are exactly same. It is 0.1, they are very similar. Okay, if it is the angle becomes like the cosine. If it is 1, the value of cosine theta, right? So then it would be like really off, completely off. Okay, completely irrelevant, we can say. Okay, depending on this value. So they are connect to like 0 to 90 degree. Okay, so no like sine and cosine already. So yeah, so how as this angle increases, they are not similar, we can say. Okay, as this decreases, they are more similar, we can say. Okay. So yeah, so here when it says traditional search, right? So what happened in traditional search was like earlier, let's say in NLP age, where natural language processing before this LLM, in the era of machine learning or deep learning. Okay, before this LLM and everything. So what we did was, so we used to take like set of words. Okay, if there are like 100 words, 100 different words that's been spoken in a document, we would have every word. Okay, there could be 100 dimensions. This first word, I am, great. Okay, all these 100 particular columns, and in each for each statement, we were checking if any of this. Let's say the first statement had 10 words. Okay, we used to mark if it has I, we used to mark it as 1. If it has am, we used to mark it as 1. So if it doesn't have great, we would mark it as 0, and so on. Okay, for second statement, the same. Okay, it may have some 20 words among these 100 words. For 20 statements, it would be 1. For all others, it would be 0. Okay, so yeah, here also we were creating coordinates, but we don't have any concept of vector database. Okay, so what we did was, so depending on like if those words are present, okay, we would retrieve this. If those particular words that's being queried, if they exist in this particular format, right? So we would retrieve this as a context. So here, what was the issue was, so we never checked on the what it actually means. Okay. So let's just say, so Arya is good with AI was the statement, and the query was, so what does Arya usually does? Since Arya was both common in both the query and the context given, right? So it would fetch that query. Okay. So the meaning is completely off. Here, the no meaning. Meaning was never understood here. Here, the semantic search, here it actually searches for meaning with the words. Okay. So vector clustering is how it arranges in a like vector space. How these vectors are arranged depending on that coordinate. Okay, that is what being discussed here. Understandable, guys? Any doubts here?
We are good. We are good.
Right. So yeah, please let me know like if it gets confusing. Sometimes giving more examples actually confuses. So that's fine. So yeah. So I said here is an LLM, okay, which is our main engine. So we are connecting it to some external knowledge base. Knowledge base. Okay, it's an external knowledge base. So we have a query which we pass. So using this external knowledge base, this LLM is responding. Is this the structure which you have got in mind now? Yes. So this is exactly what you have in mind, your mind, right? So there is a query. This is a user query. Okay. So now without RAG, it's just LLM answering. With RAG, there is an external knowledge base that's being connected to this LLM, and this is the response. So it is generating a response. Correct, Monogna?
Yes, yes.
Yep.
Actually, yeah, let me keep it this way. Okay. So how this external knowledge base is connected anyway? So we'll understand this. We'll understand more on this particular section. How this external knowledge base is connected to like LLM. How the search actually happens. Okay.
Mhm.
So there is something called vector database where all the details of like all the vectors actually like. Okay. It may vector database includes like coordinate of that vector, the actual text of that vector, and also if any metadata exists. Let me write it down. It would be easy for later reference. Okay, what does vector database have? So the actual vector representation, the embedding coordinate, right? So that one, and then if any metadata is needed, yeah, that metadata for that particular embedding, and comes the actual text. Okay, these are the three things which the vector database actually lies in. Okay, so not exactly, but yeah, for now you can think so. So here, this vector database is actually multidimensional space where all the vector actually lies. Okay. So whenever you provide some external source, we can't just plug in any textbook into this LLM. Okay, there is a certain way which we need to follow. Okay, so let's discuss on like what's the way. So what I could do is, let's just say there are 100 lines of paragraph which you need to provide, which you want to provide it as provide to an LLM as an external source of knowledge. Okay. Now what you need to do is, so let's make it 1,000 lines. Okay. So adding up 1,000 line as a context is impossible, right? For any particular LLM, let's say OpenAI or Claude, okay, they do have some context limit. Imagine adding up 100 lines of paragraph. Okay, this is more like some 100,000 words. So this is completely impractical, correct? So there is limit width. So why this rag is important? Because there is a context limit that's defined. Okay, we can't pass textbook in order to answer every question that's written on that particular textbook. Okay, that's completely off. So what we do is, so we split these 1,000 lines into 100 lines, okay, 100 each. So we would be having 10 particular, so 100 lines. So can we say 10 chunks of data? Okay, so this 1,000 lines of paragraph, I have divided into like 100 lines each, and these 100 lines, can I say it as a single chunk? So can I say collectively we have 10 chunks, right? Now what I will do is, I will pass this individual chunks through my embedding model. Okay, so this embedding model, they are created as you train the LLM. They can actually convert any text into embedding already. Okay, so yeah, this embedding model, we are passing this each chunk. Okay, in a for loop, well, let's say we pass each chunk to this embedding model, and this embedding model responds back with particular vector. Okay, so let's say for first 100 lines, we are passing it and you are getting a vector. So this is first vector. So add up your original text. Okay, and you add up any metadata if you want to. Okay, and then you make it a single unit. Okay, similarly, we will have 10 units after passing like all the 10 chunks. Correct. So depending on the vector coordinates that's been generated here, so these will be fill into this database. Okay, so now we have like 10 vectors which are somewhere in this space. Okay, they are arranged in this space, particular space. Okay, so now let me just clear this. Okay. So now user comes in, user provides his query. So the first thing that would be done is, so this query is passed into that embedding model. Okay, so the embedding model which actually converted all the chunks, okay, into vectors, right? So the same embedding model results. Okay. So this will be part to the vector DB. This vector DB will create a temporary location, okay, of this particular vector, and it checks for similar vectors. Okay, imagine this temporary vector somewhere lies here, and these are the similarity vectors. So let's say it is chunk 2 and chunk 3. Okay, so we are basically asking that vector DB to return two vectors, two similar nearest vectors. So chunk 2 and chunk 3 are very near to the this temporary vector that's been created. Okay, that is query. So now it gets chunk 2 and chunk 3. Okay, this vector DB actually responds back with chunk 2 and chunk 3. Okay, this is external source now. And you have already have prompt, correct? So now this prompt chunk 2 and chunk 3, it creates a mass, let's just say a super prompt with the context. Okay, context is already here. Now this whole thing is passed to large language model, and it has got a prompt to respond to and the context that's needed in order to answer that prompt. Okay. Now with the LLM's intelligence, it actually responds. Does that make sense?
Yes,
Yes.
yes, yes. Yep.
Yeah. Yes.
Right. So now it makes sense, like adding an external knowledge source. So how it is actually acting and how the searching is happening. So we haven't discussed on how the searching is actually happening. But we have an analogy that it is getting the nearest vector, and depending on that nearest vector, what's decided, right? So the text. So yeah, you need to understand one thing. So when I studied this for the first time, okay, so I understood this embedding is the embedding itself is responded to this LLM instead of actual text. Okay, now the prompt, that's the embedding. LLM understand the maths. So Similarly, everything is being passed. Okay, that's not how it works. So the prompt which we sent earlier, right, user query, that is the only prompt that's being sent, not the vector that's later created. Okay, this vector database, what it does is, and this embedding, what it does is, so it converts the user query to embedding in order to fetch the nearest vectors. That's it. Okay, once we get the nearest vector, the chunk associated with that vector. So here we have meta sets, right? So this vector is chosen. Now the chunk associated with this particular vector. Okay, this text. The text itself is being passed to the LLM. Okay, this everything is a prompt. This prompt could be structured something like uh, user query. Yeah, we have user query, and here is context. Okay, this is the context, and some system message, something like only use provided context. Okay, to answer my query or user query. Okay, something like this. The information is given to LLM. So it actually passes through the context. Okay, the context is already present. So now it reads through it and tries to answer the user query. Okay, yeah. In this case, it may hallucinate. Okay, that's LLM's problem. So we'll how to deal with it. Yeah, we were already exploring on that. But yeah, now depending on this context, it has to respond. Okay, so this everything, this super prompt, what I'm saying is this prompt is user prompt. It is text, English readable text, and this chunk 2 and chunk 3 both are text. Vector database actually searches for that particular vector and responds back. Okay, responds back with this whole set what's we passed. Okay, so now the text that's been recorded, right? So we will be passing the text to LLM, not the embedding itself. Understandable?
Yes.
Right. Yeah, so this anchor, slice, and stitch, yeah, that's being discussed. So what we will do is like, so we are marking the things, right? The metadata, the text, the embedding. So that is anchoring. Like this particular 100 lines of text, we are checking it. We are anchoring this, and then we are yeah, this 1,000 lines of paragraph, right? So we are slicing it into 100 lines. Okay, this anchoring is like how we are splitting it. So here we are blindly splitting it as 100 lines. So usually this is not the way we should do it. Okay, now simply you can't figure out like, let's just say today I'm in mood and let's just say 120 lines I will chunk for every chunk. Okay, so that's not how it's done. So this could be done in like different ways. There are different ways to do it. So for now, our anchoring method is just to split it in 100 lines. Okay, the slicing, the actual slicing of 100 lines that's happened, and then stitching is now you are associating this with like you are creating vector, embedding everything and database, and then you are stitching the whole prompt to create the super prompt, right? Okay, the example would be, so yeah, the anchors would be something like metadata, speaker, document ID, okay, or let's say for it, there is a classic example which I recently worked on. So there is a meeting transcript. Okay, so these meeting transcript are like temporal data, right? So the first 10 minutes somebody speaks and continuous, right? So it is dependent on time. So let's just say I'm chunking depending on 10 minutes. Okay, that's my anchor. So I'll be splitting the whole meeting into like 10-minute sections, and depending on like whatever discussed on the 10 minutes, I'll be creating the chunks on the same. Okay. So yeah, anchor we tag like speaker, document ID, meeting data, meeting date or timing, or that could be anything. Okay, that's anchor for us. And slice large file, let's say 3-hour transcript are chunked into 500 words. So here consider that my anchor is like 500 blocks, 500 words. So for each 500 words spoken, I'm creating a chunk. Okay, I'm splitting that and then I'm passing those into like embeddings. The vector DB finds the top relevant slices. So this happens when the query actually the user query comes in. This user query is converted to embedding, and this is passed to vector DB. And depend whatever the relevant vectors, right? In our case, it was chunk 2 and chunk 3. Okay, the text of these are being passed. They are being stitched as a single text, as a context. Okay, so that's what being discussed in stitch. The vector DB finds the top relevant slices. which are then stitched into LLM prompt. Okay, now we are passing this as context. This whole thing is context. We are not dividing it as check 2 or chunk 3. Okay, this whole thing is a text that LLM can read through now. Understandable how this anchor slice stitch, we discussed it previously, but yeah, this is a method which is used in RAG in order to actually create vector databases. Understandable? Any doubts here, guys?
No.
No doubts? Any doubts, Saurabh?
No, no, no.
Okay, right. So yeah, just remember that anchor slice stitch. So anchor is something through which you decide to divide, and slice is something you actually divide, and stitch is something that comes into play when user query actually comes in. Okay. So yeah, the process of actually doing the slicing and creating chunks, right? That is what chunking actually means. Okay. Yeah. So yeah, let's say so we have been working with the local models, right? So I thought like let's check on like how this rack can be built in my local. Okay, instead of having some fancy tools and API calls, right? So let's try to build something in my local and so that I can understand each part of it. Okay, that was the agenda. So what I did was I used ChromaDB. Okay, so if you guys are familiar with SQL or databases, right? So we have something called SQLite. Okay, which actually is a file system. So instead of creating database like MySQL or PostgreSQL, right? So with this SQLite, we create database in our file system. Okay, so similarly, this ChromaDB, what it does is, so it creates vector database in my like local system itself as a file. Okay, this Nomic, what it does is it's an embedding model. So we have Llama 3.2 in our local. We have 5.3. So all these can actually create embeddings. Okay, no worries. But the issue here is, so since these models are optimized for text generation, okay, they are optimized for text generation. That's why creating embedding is not like their main work. They can do it. Okay, we can create embeddings with our local models, no worries. But it will be of way slower. Okay, so we have certain embedding models, some models like embedding models, which are actually trained to do the optimized to do the task of like creating embeddings. So we can use those. So Nomic is one such example. Okay, which I have installed. Yeah. So yeah, it's like Llama pull Nomic embed text. Okay, that's the whole thing. So by doing that, you can actually install download this model. Now, if I took Llama list, now this model should be listed for me, right? So yeah, Nomic embed text is listed. So this is like specifically embedding model. Since it is not specified for embedding model, so you can see the size. It is very less, right? So 274 MB. So all other models are like in GB. So yeah. Okay, so we can use VectorDB for our local vector store, and Nomic this is for like creating embeddings. Okay, so we can use any of our models, Llama 3.2 or 5. As of LLM models is concerned, we can do it, and you know it, right? Yeah. So what are those major metrics? So we check through LLM metrics, right? So day before yesterday or before that, we check through LLM metrics. So what are the metrics we should check for? So what is with the RAG? Okay. So we have to check for context precision. So how good my RAG system is? How good is my retrieval? Okay, we have a retrieval process. We are getting the vectors, the relevant vectors. So is my vector database actually searching through and getting me the actual relevant vectors, or is it hallucinating? The hallucination doesn't happen here, but yeah, depending on different chunk methods, right? So I'm with 100 lines of chunks, right? So I'm actually cutting off the information. Imagine this had some information, this had some information, but the meaning could be completely different. Okay, this could be have some first half of the movie. Okay, this could be second half of the movie. Okay, so there could be this is more dramatic and love, but this is more of horror or action. Depending on that, the vectors created for both could be different, right? So that's why the chunking method on the anchoring, the anchors we are looking for, right? So that should be very good. Depending on it could be depending on temporal data, it would be depending on like storyline, or it could be depending on which type of text are we dealing with. Okay, could be meeting transcript. So depending on that, we have to decide the anchors. So blindly putting on a number is not an efficient way. So that's why from this, if vectors are created, right? So the retrieval step may go wrong. Okay, so imagine you are using a different embedding model in order to have these vectors, and then you are using some different embedding model to actually query the database. Okay, so essentially you are converting the user query into vectors, right? So if the embedding model changes, okay, let's say model A was used to create all the knowledge source, and model B is being used in order to actually convert this user query into vector. Okay, now these coordinates could be different completely off. So the resultant relevant query could be completely off. Okay, again, in that case, the retrieval failed. Okay, and there could be more. Okay, by adding this complexity, we are actually adding up more testing methods. We are adding up more techniques where it could fail, and more edge cases. Correct. So that's why this context precision is very important. That is retrieval. Retrieval has to be precise. Then the LLM model, if it is good enough, it responds back pretty well. Okay, and faithfulness. So yeah, imagine this retrieval method is too good and the context is very accurate, but the LLM, the main engine, is actually not focusing on the context, and it is generating what it actually trained on. Okay. Uh, so that faithfulness, how grounded it is to the context provided. So with this RAG systems, we need to check this faithfulness as of LLM's stage, and context precision as of retrieval stage, and answer relevance. Depending on what's being generated, right? We have to check through the answer too, because yeah, this may be correct, this may be correct, but the context itself may be wrong. Okay, so imagine the whole vector database is filled with Arya's personal life. Okay, but the question was something about Arya's professional life. Okay, so yeah, this retrieval gets any similar vector. Okay, and this faithfulness, this LLM is generating the answer, but the answer is completely irrelevant, maybe because there is no space of like personal data here. Okay, the question is about professional data, but we have only personal data as of our context. So that could create answer relevance issue. Okay, so this we need to check with this. So these are the main three metrics which we would be needing, very essential in order to evaluate any of the RAG models. RAG systems. So yeah, so I have mentioned like few of the usual failure area. Okay, so if it is I don't know the answer, if we given strict instructions that if the context is not present in order to answer the query completely, respond back with I don't know the answer. Okay, so that may be clear retrieval engine's fault. Okay, we can make sure that it is a retrieval engine fault. Okay, if this is the answer from LLM. Incorrect factual claims. So LLM is answering, but it is creating the thing. So it is creating its own facts. So that is hallucination. That's model's problem. Answer is too technical. Okay, this could be something like prompt engineering problem. So whatever the system prompt we have provided, right? So that could be something of, okay, imagine somebody saying like, don't make it technical and try to always respond back with as in like child. Okay, so that could be prompt engineering problem. Low context precision. This could be vector DB or how we created the vectors. That could be the problem. Okay, so the anchor methods we used, that could be the major problem for us. Okay. So in RAGs, these are the failures, usual failures. These are not the only ones, but and what are the reasons for them? Associated reasons, which you mentioned here. Okay. So yeah, we checked through RAG systems, and I hope with this session completed, at least theoretically, if somebody asks what is RAG and how it works, or at any point of step, what happens, maybe you are like able to answer them. So any doubts?
No. So, are we learning on some like Python code for RAG testing?
Yes.
Okay.
So again, here also deep eval, we can use it. You can use the same framework. So in order to test all these things, all these metrics. Okay. So we'll be discussing on deep eval again later with this RAG also. So Manoj, any doubt until this point?
No, Arya, I think my doubt is being answered. So
Okay. So you had that doubt, right? So is it clear or?
yeah.
Okay, great. So we have a small piece of code which we can run. So in order to use this code, you have to install in your terminal, just put up pip install ChromaDB. This is the line. Okay, that installs ChromaDB in your Python. So with that, you can create, like it creates a local file system which also acts as your vector database. Okay, for local database, yeah, this is great. Okay, I'm creating this ChromaDB here in this environment. I'm creating some file like local ragdb. Okay, within which all the vectors I'm passing are being sent now. All right. So yeah, I've installed like imported ChromaDB. That's the major thing. So here is the location which I'm providing it. Okay, save all my this particular session's vectors into this particular file. Okay, that's the instruction. So this collection is actually creating like a table, a space into my database. So database may have like different sections, right? So different tables could be arranged. So this is like having a particular table. Okay. And then this is my local Llama model URL. So get embeddings. So here I'm using, so for usually for generate after API, bar generate will come. For embeddings, it is bar embeddings. Okay, the same URL, but yes, embeddings. So here I'm passing the model name, that is Nomic embed text, and the prompt is, yeah, I'm still not passing the prompt directly. Yeah, I will be passing it. So I'm asking it to respond back in JSON format. Okay. Yeah. So whatever the response comes in within which there would be something like embedding. Okay, that's the key, and the value of it would be the original embedding. So I'm extracting those. So here is as of now, imagine this to be like our whole book. Okay, we have three statements, three chunks. Okay, so these could be like 500 lines of text. No worries. Okay, for now, for example, I have just taken these three statements. Okay, they are my chunks. So now here with this for loop, I'm actually going through all the each chunk. Okay, and creating, as you can see, get embedding. This is the function which we designed earlier, right? So I'm passing text to it and it responds back me with like the embedding. Okay. So this text is being passed and we are getting the vector embedding. That is, we are passing it to vector math. That's the variable that's holding that vector embedding. And then, yeah, I'm actually printing the dimensions, the number of dimensions to check on the number of dimensions. So this vector math is a list of numbers. Okay. So when I say length of list, which actually represents the number of dimensions, which we will see once we run this. So the actual vector, okay, we will see that also since it is in print statement. So here I'm adding into that table, I'm adding collection.add. Okay, this method actually adds this particular data into its table. Okay, so ID, okay, I'm creating ID. So three things. So here I am associating it with the I. So that should be like ID number 0, 1, 2. Okay. Then the embedding, the actual vector, and the document. So the text, the original text. Okay. Once all the three statements are embedded and passed to the database, vector database. So we will get to see the message database populated successfully. And then the retrieval comes in. Here is the user question. how does a customer actually get their money back? Okay, so that's the classic user query we are using across. Okay. So here, yeah, we are printing the question. So we are converting, we are calling the same function to convert our user question, user query into embedding, and we are storing it into question vector. And again, we are checking the length of it. Okay, the length of all the 4 vectors, query vector and all the 3 chunks, right? So they should be similar. And the vector representation, we are printing it. And as of result, so we are querying our database, okay, to get at least one chunk, one relevant chunk from that query. So if you pass it as 2, 2 chunks will be fetched. If you pass it as 3, 3 chunks will be fetched. Since we have only 3 chunks, so let's pass like only one. So retrieved context, yeah, that's our retrieved context. So vector DB found this, okay, retrieved context, yeah, it will be printed, no worries. And the final prompt, you are an helpful assistant, use only the context below to answer our user's query. So here is the context. So whatever the text we queried, right? So we got as a similar relevant chunk. So that we are adding it here. So that this is our super prompt. So we are adding a user question, okay, user question. And then how we usually do to generate the answer, yeah, we are doing the same process. LLM response, request library. We are generating it using Llama 3.2 model. We are passing our final prompt here. That is our super prompt. Okay. So yeah, with this, maybe we just revise the whole thing. Okay, let's just run this. So slicing and embedding document. Okay. So the first chunk is created already. It is of 768 dimensions. Okay. So if we go through this vector, so they could be of 768 coordinates will be there. First 3 chunks, first 3 statements. Yeah, all the chunks are created. Database populated successfully. User queries, how does a customer actually get their money back? And this is also of 768 chunk. Okay. And the vector representation, it's given here. And then comes vector DB found, UAT meeting part 1. And yeah. So this is the actual context that's fetched from the database. Okay. It queried the vector database, and this is the actual thing that coming. And it is generating an answer. So here is the whole answer. So I'm printing the answer 2 times actually. So if I remove this, only one time it will be printed. So yeah, model 3.2 created timestamp response based on the context. It is not explicitly stated that how the customer would receive their money back. However, we can infer that the meeting would likely discuss the logistic and blah, blah, blah. The response is generated. So does that make sense? The whole code?
Yes, yes.
So yeah, I will share this code. So you can add up like a few more context here. Okay, you can add up any number of lines, whatever you want. The text, you can just open any PDF and copy a paragraph, maybe like 100 to 200 words. So this rack itself is like a newer, like it's been like 2 to 3 years it's came in, and it is very essentially used into any production environment or any companies. Okay, so this itself is could be termed as whole subject. Okay, different anchor methods, different slicing methods. So how to optimize our vector database, which one to use, so how our embedding should be. Okay, what are the models, embedding models we can use. So that itself could be like uh, a topic which could be discussed for like 10 to 15 days. Okay, but that's not our agenda in this particular session, or it may be in this course. So yeah, we have understood the overall structure on what happens with the rack and how it works. So that should be enough. So you can add up any number of text, any number of lines here. Okay, so you can populate the list and you can give your own queries, and you check through if the relevant context is actually being gained here. Okay, try to play around with this. That it may be interesting. So yeah, I will share the file with that code. No worries. So any doubts,
No.
guys?
No, good. We are good.
Okay.
Yeah.
Right. So Manogna, is it overwhelming?
Yeah, actually, it's fine.
Saurabh, how do you feel? Are this concept like too much or
Yeah. They are definitely too much. I think, since we are seeing it, listening it first time, seems to
right?
be challenging for us. But let's see how it goes.
Sure. If you could, like, if you go to Insta or let's say LinkedIn and you see any rag memes, if you have understood, if you did understood that meme, right? So then I can assume that my class was good enough. Okay. Sure. Then I will share the file. No worries. If no doubts, we can end the session. Thank